Example 8.6. Two identical springs of spring constant K are attached to a block of mass M and two fixed supports as shown in the figure. Show that when mass is displaced from its equilibrium position on either side, it executes a simple harmonic motion. Find the period of oscillation. Okay, so there is a one spring and sorry, one block and two springs. Okay, this is like this. This is our block of mass m. There are two springs are attached to this block. Okay, like this. It is one spring and this is another spring. These are the rigid supports. This is also rigid support. Then the spring constant of each uh, spring is same, that is equal to K. Then now we have to find out the sorry, after if we are this is block this block when it is in equilibrium position, that x is equal to 0, then we are applying some force here. This is means this block we are taking one of the side, maybe this side or maybe this side. We are taking to this side with some external force, that is uh, F external force. Okay, so because after applying that force, this block has moved up to here. Okay, like this means it is displaced towards right. Okay, the displacement is here from here to here, that is equal to x. Okay, so means uh, by taking the block towards right side, and then after taking the block towards right side up to here, then this spring is compressed like this. It is compressed because the block is moving to this side, and this spring is elongated. It is elongated like this, means there is some extension in the spring. Okay, so now then after releasing that external force, this block is executing simple harmonic motion about its mean position, means this block is oscillating about this mean position which is in straight line, and it is executing the simple harmonic motion. If it is executes simple harmonic motion, we have to find out the time period. So first of all, I'm writing something here about this. Okay. If block displaced right side by x, if block displaced right side by x, the spring the spring elongated elongated by x on left side, left side, and and compressed compressed by x, compressed by x on right side. Then the forces acting on block. What are the forces are acting? forces acting on block. Okay, there are two kinds of forces are there. One is the external force, and after applying this external force in the string, there's what spring force, that is restoring force, will be developed. That restoring force is acting towards mean position. This is I am taking here F. Okay, that is F2, I suppose. Okay, so external force in this direction means it is compression, then it is pushing the block towards mean position by F2. This is our restoring force F2. And here is also it is extended. So this spring is also extended, means elongated. So this is also pulling, the restoring force also developed in the spring also, and it is pulling the block towards mean position. That is also acting towards the mean position. This is our another force. Okay, so which is acting F1. Or suppose it is one spring, it is a second spring. Okay, so this restoring force is acting towards the mean position, because it is pushing the spring is pushing the block towards mean position, and it is elongated, means there is an extension, and it is also bringing towards the mean position. So F1 and F2 both are acting towards the mean position. Okay, this F1 and F2 are restoring forces. Okay, so then that is first one, that is force F1 according to our Hooke's law. According to Hooke's law, force F1, that is equal to minus k into x. Okay, then this F1 force by this spring, it is bringing towards the mean position. So this force, it brings black towards mean position. Mean position from 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 right to left. From right to left. And second restoring force, that is F2 is equal to, that is also minus kx, and brings black it brings the block towards mean position from right to, this is also right to mean position, same as like that. So this is we called here a pull. Okay, so the here F1 is pulling the block, and this F2 is it is pushing, this spring is pushing the block towards the mean position. Then the total restoring force acting on the block. Okay, so total restoring force, that is Fr is equal to F1 plus F2. Okay, so according to this, this is equal to how much? Restoring force Fr is equal to minus kx minus kx, and Fr is equal to minus 2kx. Okay, this is the total restoring force. Then right to means this is nothing but here it is equal to m into a. Okay, f is equal to m into a, and this is minus 2kx. From this, a is equal to minus 2k by m into x. Here a is directly proportional to minus x. That 2k by m is constant. If you are removing that constant, we are getting, sorry, if you are removing the two proportionality symbol, we are getting some constant, and that is equal to 2k by m, and it is executing simple harmonic motion. So if it is executing simple harmonic motion, we should compare it is with the compare above equation with a is equal to minus omega square x. So if we are comparing this omega square x with this one, then we got omega square is equal to 2k by m. From that, omega is equal to under the root of 2k by m. Then time period t is equal to 2 pi by omega. So that is time period t is equal to 2 pi by, this is under the root of 2k by m, and that is equal to 2 pi under the root of m by 2k. This is our time period.